Hi everyone, this is Apollo. Today I'm going to demo how to create a virtual scroller, or implement virtual scrolling with pure JavaScript. So, what is virtual scrolling? What problem is it trying to solve? Let's say you have a table or a set of data that has there could be a large amount of data in it. In this one, we have columns and rows. It's a table, so you could have 10,000 rows, 100,000 rows, a million rows, and you want to be able to display those rows on the page without sort of killing the memory usage that Chrome does and killing the performance that it's trying to do in order to render those elements. So here I've created a table, and the number of records for this particular data set is a million, and I can actually take it and scroll all the way to the bottom without any real impact on the memory and the CPU usage for the Chrome browser. So the principle is behind it is pretty straightforward, but you can see it starts at 0, and then you can scroll down to like 235,099 and scroll down to some more and get to 800,000, and ultimately scroll down to the very bottom to get to 999 900,999 records. So um, it's the way to this is pretty straightforward. So all the code that you need for this particular demo is out there on Bitbucket. It's Bitbucket Apollo Rocks Pure JavaScript. Just clone that, and you can see sort of what's going on. So let's go over a little bit of the code and how everything is set up. Let's go to source tree first. This is what the visual tool that I use in order to interact with Git and Bitbucket. So the version or the check-in that you want to get is this 2.1 virtual scrolling hookup and cleanup. That's what this particular video is going to base stuff on. Alright, so if we look at the index.html, what we're doing here is we've got a body, we've got a div, view element, child view element. We're going to render our table into this child view element, and the view element, its width and height is fixed. If you look at the DOM, or the structure for this particular page, you'll see that this view element, it's got a width of 500 pixels and 300 pixels as the height. So it's a fixed amount of view, and you're trying to display a million records within there. The child view element is the one that is going to contain all of the records that we're trying to display, and that's where we want to render our 1 million records in, or pretend to render, or virtually render a million records. These are the columns that I'm highlighting, and the reason that they're sort of outside of the child view is because we want that to be fixed, so the columns remain visible at all times. So that's the DOM structure of things. From code, what we're going to do is we're going to wait until the document is ready, and when the document is ready, we're going to do some things. We're going to get the view, which is that parent view, the main view that we're going to render stuff in. The child view element is where we're going to put all of our virtual rows that the user will actually be able to see. Generate data, we're going to need a million records somewhere, so we'll just manually create that. It's going to be a lot easier than trying to put it all sort of statically within here. View size just tells us what the size of this particular view is. So we can get that from the element, the view element there. Table renderer is what's going to render our records into that child view, which is going to sort of sit within this parent view. And then we are going to calculate the table height based on the data that exists, and then we're going to create a scroll bar and attach our view and child view there so that this is going to control sort of what's being seen. The main method here is when you're rendering things, essentially when you scroll down somewhere, you want to know the visible, what's visible to the user, and what data can be rendered within what's visible based on where the user has scrolled. So that's the main logic. You're only going to display or create the elements that you need in order to for the user to see that data. Anything else you're just going to remove from the page. So that's how we can keep low memory usage, low CPU usage, and sort of have things be more performant and more efficient. All right, so get view, all it does is it goes and finds the view element that we've sort of specified here. Child view element, get child view element. It just gets that element with that ID. And then generate data, we have this address generator. So if you look at address generator, all it does is when it does create data, we're going to create this data property for this instance of that class, and we're going to create fields and rows there. We're going to have the names, the index, first name, last name, address, and then we'll just count to 1,000,000 and push records into this row array, and it's just going to be just this name, first name, last name, and the actual address. Now, in real life, you'll probably want to present maybe 1,000 records at the most, but the principle is the same. You know, to get 1,000 records from the server, it'd probably take a lot. To get 100,000, that would take a lot. 10,000, it's still a lot of records, but at least it'll be doable to show a large amount of data. 1,000,000 is just, you know, for the wow factors, like, hey, I can actually view 1,000,000 records if I wanted to, which you can. All right, so what's the next one? We've generated our data, and so now we need to get the view size, and all we're doing is taking a look at that main view element and getting the actual width and height of that element, and we set the style so that we fix the width and height, 500 pixels and 300 pixels. And then we have this table renderer, and the job of this table renderer is to determine what the viewable portion, or how big the view element is, and what data will fit or is sort of would be encompassed or be visible within that view based on some scrolling. So calculate table height, again, this is just the table renderer would know about this particular data structure, which is a bunch of rows, and it'll have a row count, have fields, and it'll have, you know, it'll take up a certain amount of height, and then the rows themselves will take up a certain amount of height if it was rendered fully on the screen. But since we're only rendering parts of that, we can, based on sort of where the scroll position is and what's visible on the screen, we can determine what data needs to be rendered or created HTML elements for. Scroll bar and attach views, or create scroll bar and attach views. We're using this bar scroller.js. There's another video in this same playlist, a virtual, or how to create a virtual scroller using JavaScript. Take a look at that and how it behaves. Essentially, it's just a scroller that lets somebody who's interested in when something has been scrolled, notifies that client, and then that client can take action on it. So what this does is once everything is set up, we've got our view, our child view, generated the data, we've determined the view size, and we have a renderer, and we know the height. Let's see, calculate table height. We know the height of the data if it was rendered fully, and we created a scroll bar that allows us to scroll through the data. Once we have that, the renderer will just go and create the data, or create the HTML elements to reflect the visible data. So let's take a look at table renderer, which is the one that's responsible for really doing this virtual drawing of our table. This extends from renderer, and the main functions or functionality within renderer. You have a constructor. It takes the view that it's going to render into the size of that view, which is the visible size of that view, the data, and then it's got some properties. It's got some start visible, end visible, which is what part of the data, if it was fully rendered, what the pixel position are in order to render that data. And then calculate size. We're going to return width and height. Set data. Obviously, we need to keep track of the data. And then render is where we actually render the visible, the data that would be visible if it within that particular view element. So let's take a look at table renderer, and we have we're just calling the base classes constructor, setting our row height for our data to be 20. The start, so we'll treat the rows as this as a start visible row, and we'll know like which row is first visible, and somewhere it's gonna have the row that is not visible as well. But headers is going to contain our elements that render the actual columns for the tables, and we're going to sort of clear that, recreate the header every time we scroll. So calculate size, it just goes through and make sure that we have fields and rows, and the height of this particular view, if it was fully rendered, would be the number of rows and the row height, and then include just the column height there too. And then let's see, calculate or to actually render it, we're going to clear the view, which means that we're just going to take the view and clear out the contents of it. And I think there's a faster way to do this, and if you look at Google, there's some faster way to sort of clear out all the child elements that's within the view. But for now, just do this because I think it can loop through and get the child nodes and delete them one at a time. And then we're going to calculate the visible rows, which just means, let me see what that means. Calculate visible rows, and all it's doing is at some point, well, render says what's visible. If we fully render our row or our table, what at what position would within that fully rendered view, what's a starting pixel that view sort of starts making things visible. So if you look at this, the start visible would be 0 as you scroll down. Virtually, like all this, like there's GUI all the way underneath or below this particular view. So when you scroll, you want to know, all right, what's the starting position that this part is visible within the view. So you're really translating the Y position that starts to be visible and the end of the Y position that stops being visible in order for you to figure out what row is visible to the user. Alright, so calculate visible rows just says what's my start visible row and what's my end visible row. And I think there's an error in this should be end visible row. I just put visible row, end visible row there, so it's okay though, because when you assign this end visible row, it just automatically creates a property, and we're using end visible row anyway. So you take the start visible and divide it by the row height, take the floor of that just to make sure that we don't have any rounding errors, and then take the ceiling, the end visible, divide by the row height. So in our data, we know what's the first visible row, what's the last visible row, and then once we know that, we can render the header, and the header just clears it out. We're going through each of the fields, and we're creating a bunch of divs from left to right. And this is one important thing here is we're appending this particular these particular header elements into not the view, but the parent of the view, just to make sure that they float. Alright, so then we do render rows, and render rows just goes and it goes through every it we start with the first row and last row, and we figured that we calculated what those were before based on the start index or the start visible position and end visible position, and we're making sure that the first row and last row are sort of within correct bounds. And then all we're doing is we're saying field width is we're trying to fit all the columns within this view. So if we have 1, 2, 3, 4 columns, we just divide the total view length by the number of view columns. And then the row height is whatever we specify the row height was going to be. And then we're just going through the starting with the first row, ending with the last row. The top is going to be let's see, top is going to be that row height plus, what are we rendering here? Yeah, these are the rows. First row times row height, and then we're going through each of the rows, and then we are going through each of the fields. Here's the row. Going through each of the rows, starting with the first row, and then going to the last row, and then we're rendering each row. Now we're rendering each field, and we're creating a div for each field. And the position, let's see if it's, I'm trying to find, oh, there we go, top. Div style.top is that, left is that. So the only thing that I'm sort of leery of here is we start at the top, first row times row height is the top. That doesn't seem right to me for some reason. Top should be let me think about this one. Yeah, I think that sounds right, because we're not rendering it relative to. So if you look at this, we have a view element and then a child view element. We're rendering it relative to this child view element, right? So really, that is the correct position. We have, when we're scrolling, we're taking the child view and sort of pushing it up towards the top so we can see towards the bottom. So yeah, that's correct. We're still the position of the row should be relative to the view, which is a child view element relative to this table renderer. So it's going to be the row. You start with the row height, which is just the space for the column fields. And then the first row is the first row that's visible times the row height. So that's correct. And then we just iterate through each field, render it at that particular position. The left is going to increment as you render the row, and then the left resets to 0, and then the row height, you just add another space for the next row. That's pretty much it. So nothing super special here. What we did was we, again, just going through here from a logical perspective, all we're doing is we're clearing the view, the child view, calculating, figuring out which rows are visible, rendering the header, which clears out the headers first, and then renders each column as an element, and then render the rows, which just figures out based on the start and end row, and the offset from the top renders each row and the fields within the rows. So I think it's pretty straightforward. Check out the code. Why do I do this in JavaScript, why do virtual scrolling? A lot of libraries that are out there like Angular, possibly React.js, just a lot of like macro type frameworks. Once you start getting a large number of elements onto the screen, it becomes very sort of laggy because it has to respond to events. When things are changed, a lot of elements are updated. I guess it's another issue, but when you start trying to render more than a certain amount of elements on the page, the CPU performance gets pretty bad and the memory usage gets pretty bad. The memory usage for this one is pretty low. Let's actually go in and take a look at where we are here. Let's see. Activity monitor. Let me bring that up. And so if you look at the memory usage for Google Chrome, and let's just go and do Chrome, it's 239, and if I refresh this, it doesn't change much from what it is. And as I scroll through this, nothing changes with the memory. 293.2 for a million records. And if you look at the CPU usage, this is at 10.8%, and we'll start scrolling here. So it doesn't really change much. I think that is probably more due to the visibility of those elements at the debugger there. So let's do that, and let's start scrolling. So performance wise, it has very minimal impact on the screen, on the CPU. So all right, that's about it. Check out the code from Bitbucket, and let me know if you have any questions. Just leave it in the comments, and I'll try to answer it as best as I can. Thank you, everybody.